Now let's speak about NAT types. So in general, we're not going to speak now about configuration options, just what are the NAT types, the NAT options, which kind of NATs we can perform on any NAT devices, of course, assuming they support all of the NAT types, which of course most of them support all of the NAT types nowadays. So we have static NAT, which means you're going to configure a manual or static binding of one IP or one subnet into another IP or into another subnet. And because it's a static NAT, translation is always active, it never expires. And because it's always active, it means traffic can be initiated both ways. Of course, assuming you don't have other restriction like access list or whatever else which restricts traffic from flowing both ways. And is useful for providing connectivity between overlapping networks nowadays, static NAT. Now, static path, it's a variation of static NAT, which means you're going to do a manual static binding of one socket. So static path stands for static port address translation. So it's a variation of static NAT because you're going to translate statically or manually one socket, which means one IP and also the TCP or UDP port number, to another socket, which means to another IP and to another TCP or UDP port number. And this is useful for providing connectivity with publicly available services from the internet. Like for example, looking at our diagram in here, if this host on the inside has a private address, let's say 10.10.10.10, and this host is providing a web service, so it means TCP port 80, which I want to be reachable out on the internet. I want that server to be reachable out on the internet on TCP port 80. So what this means, again, assuming this is going to be the inside NAT interface and this is going to be the outside NAT interface, it means that I'm going to configure this router to publish or make this private host of 10.10.10.10 on port 80 to be visible on the outside as a public address, as an address of whatever 222 on TCP port 80. So it doesn't make sense to translate one IP to another IP to make that server to be publicly available on all of its services, since that inside host, that inside server of mine, runs only a service, the web service, which I want to be publicly available. So I'm not gonna translate one IP to another IP. Doesn't make sense. I'm going to translate one IP to another IP, the private to the public one, but I'm also going to put a restriction saying only for the TCP traffic on port 80. So that's called the port address translation, because you in the NAT configuration you specify not only the IP mapping from the real to the mapped IP address, but also the port mapping, which of course in this case I'm keeping the ports as they are. But it could happen that actually the inside host, for whatever reason, runs this service on port 8080. So the inside host may run that service on port 8080, but pretty much being a public service, pretty much everybody browses or reaches, accesses web resources on port 80. So in this case, I'm going to also translate port 8080 to port 80 out on the internet. So on the inside network, the server actually listens on port 8080, but from the internet's point of view, it's reachable on port 80 because as traffic flows through the router is going to translate both the IP and the port number. So this configuration in mind, when the outside host is going to initiate a traffic destined to 2.2.2 with a destination TCP port of 80, as that NAT device is going to route a traffic from the outside to the inside, is going to untranslate or destination NAT translate both the IP address and the destination port. So destination now becomes 10.10.10.10 and destination TCP port becomes 8080 because that's the port my web server is listening on the inside network. So in this case, I'm doing both IP translation 222 into 10.10.10.10 and also port translation. I'm translating destination port 80 to destination port 8080. So in general, when you want to publish a service to the internet, if that server has a private IP address, you're not going to do a one-to-one mapping IP to IP because it doesn't make sense. You're only going to publish on the internet. You're going to do a static path, not a static NAT, and translate or publish only the services which you want to be publicly available from that server. Now I also have dynamic NAT, which means dynamic NAT is still a one-to-one binding, one IP to another IP, or also you can do one subnet to another subnet, but a translation is being done on demand. That's why it's called dynamic. So if with static NAT, you statically tell the router to translate what IP into what IP. It's a static binding, always active. With dynamic NAT, based on your configuration, you tell the router what to translate. So what is the source, what is the addresses you want to translate, into what pool or range of addresses you want to translate, and the router picks up an available address dynamically from the pool to choose the translated address. So it's no longer a static one-to-one mapping. The router dynamically is going to translate source or destination and translate that source or destination from a pool of addresses that you define in your NAT configuration. And because it's dynamic, it means that translation is being done on demand as the router sees traffic, as interesting traffic shows up matching your NAT configuration. Which what this means is that because the translation is not active always, it's being built on demand, just the configuration is active always. It means that initial traffic can be initiated one way only, then translation is going to be performed by the router, and then you're going to be able to initiate traffic both ways because the translation at that point is being active in the NAT table. And of course, dynamic NAT means that the translation is going to have a lifetime. If there's no traffic back and forth, matching the translation is going to expire at some point. The translation timeout depends of course on the platform you're running, ASA, iOS, Switch, and of course on the code you're running. There are different timeouts in there. Now dynamic path or path overload, and in general dynamic NAT is very rarely used. It's used also for it's used for overlapping networks as well, when you want to provide connectivity between company A and company B, and both companies have the same private IP addresses like 10.10.10.10.0/24 and 10.10.10.0/24, and they cannot communicate one to another. And at that point, you have to translate both source and destination, but you wouldn't want to do static NAT, you would want to do dynamic NAT, because static NAT is going to always put the translation entries in the NAT table and consume resources to begin with. While dynamic NAT just creates the translation entries in the NAT table on demand, which means it's going to create only entries as needed, so it's going to be a lower impact on the memory of the router because it has fewer NAT translations in the NAT table. Now, dynamic path overload, which is a variation of dynamic NAT, it means that at this point, because you're doing dynamic port address translation, you're going to choose to dynamically bind or dynamically NAT multiple IP addresses into a single IP address or fewer addresses, which means because it's a path type of NAT, you're also going to do TCP and UDP port translation. And traffic can be initiated likewise one way, but this time for real one way only, because with path you don't do a one-to-one mapping at the IP level. You map multiple IPs into the same IP, and you also translate the port numbers to make the translations unique in the NAT table. So for that reason, you cannot initiate traffic both ways, because the mapped IP address you're translating all of the LAN addresses are going to represent all of the LAN addresses, so there's no one-to-one mapping back and forth. So dynamic path is usually used for internet connectivity. So like for example, assuming that, again looking at the diagram in here, assuming those are your inside and outside networks. And let's say on the inside network, This is your inside NAT interface, and this is your outside NAT interface, inside, and this is your outside. And let's say you want to provide internet connectivity with the inside from the inside network. And let's say on the inside we have a subnet of 10, 10, 10, 0/24. So you have two options to provide internet connectivity from that private IP address space. In order to, you can either do dynamic NAT, which means you need for dynamic NAT to work and provide internet connectivity, it means you need a public pool of addresses of /24, because you would want to assign one public address for each private IP address from the inside network. And of course, it's two problems with this configuration. One of them being that to begin with, you may have not only one /24 in your network, you may have tens of thousands of hosts. So that's one problem, because you're not going to be able to buy tens of thousands of IPv4 addresses. And of course, even if you had the money nowadays, there's no more available IP addresses in a lot of countries. You cannot even buy any more IP addresses. In some countries there are no more available IP addresses to buy. So it is what it is. That's why those countries have migrated to IPv6. So that's one problem, which means for that reason, because you may have multiple hosts, so you either cannot buy enough public IP addresses, or you cannot afford that. It means that you're not going to dynamic NAT. You're going to do dynamic path, which means you're going to NAT all of those /24s into one or multiple public IP addresses. Usually it's going to be one public IP address, which the provider is going to lease you. It's going to be an IP address of, whatever. Let's say it's going to be 99999. 9999. So as traffic flows from the inside to the outside, all inside hosts with dynamic path are going to be seen as 9999. So that's why you cannot initiate traffic both ways, because there's no one-to-one mapping at the IP level. It's a many-to-one mapping. So as for example, what this means is that, for example, as you have a host on the inside network, which is an IP address of, let's say, 10.10.10.10, 10.10.10.10.10. As traffic goes out on the internet, the router is going to NAT that address into 9999. So 10.10.10 becomes 9999 as the router routes traffic out on the internet. Likewise, you have another host 10.10.10.20. The host sends traffic to the router, and then as the router routes the traffic out on the internet, it's going to likewise NAT that address into 9.9.9.9. In order to make the entries in the translation table unique, because the router has to have unique entries in the NAT table, that's why it's also going to NAT the layer 4 information to be able to differentiate between those two NAT entries. Because this, let's say this was a TCP session with a source port of whatever, 20,000. And this one in here was likewise a TCP session with a source port of 30,000, for example. So those two entries in the NAT table are unique. So this entry in the NAT table, that's one entry. It's unique, it's not identical with this entry from the NAT table. Just because the router also keeps track of the layer 4 information, and because the layer 4 the port numbers are different, it means that the entries are unique in the NAT table. Of course, if both hosts will initiate traffic like TCP with the same source port number, which can happen, then the router is going to translate also one of the session's port numbers to make the entries unique in the NAT table. You also have policy NAT, which is a variation of either static or dynamic NAT. So you can have static policy NAT or dynamic policy NAT. You can have static policy path or dynamic policy path. It depends on what you want to achieve. But policy NAT is the same. Doesn't matter how you do a static or dynamic. Policy NAT means that translation is being done only if specific conditions are being met. So policy NAT allows one socket IP and TCP UDP port to be translated into another socket based on source destination of the IP traffic. As the name implies, because it's called policy, it means that this type of NAT is useful when you want one IP or one subnet to be translated differently based on the resource being accessed. For example, let's take this use case and let's assume that this is my router performing NAT, router 3. And let's assume that this is on the, let's say, on the right side. This is my LAN, which is going to be the inside NAT interface. And on the left side, so this is the LAN. And on the left side, this is going to be the internet. So internet, which means this is going to be my outside NAT interface. So let's assume that what I want is, I want traffic from this subnet. So as traffic goes inside, outside, and let's say it goes to router 4's address in VLAN 47. So I want to tell the router that if source is 172.16.10.0/24 and destination is VLAN 47 136.1.47.0/24. As traffic flows through my router which performs NAT, I want the router to keep destination as it is, 136.1.47.0/24, whatever that was, an IP from that subnet. But I want to NAT this source to whatever I want, the public address. Let's say 9, so into the pool of 99.0/24. So that's what I want the router. If destination is VLAN 47, I want to NAT the source into a pool of 999.0/24. Static or dynamic, it doesn't matter. A one-to-one mapping based on that traffic flow. However, if traffic from the same source of VLAN 47 likewise goes inside outside, but is destined, let's say, for the loopback of router 4, or let's say it's destined to, let's say router 4 has not a subnet in here, let's say it has another subnet of 136.1.20.0/24. So if destination is that, so if I have traffic from the same source of 172.16, let me use orange for this, that's the second flow. So if traffic is from the same source of 172.16.0/24, and destination is going to be now different, destination is going to be 136.1.20.0/24. As traffic flows through my router which performs NAT, I want to keep the destination as it is, clearly. I'm doing only source NAT, I'm NATing the private IP addressing space. But I want to NAT the source now into another pool. Source is going to be, let's say, 8, so into another public IP address space, 24. So in both flows, the source is the same. Is the same VLAN 24, VLAN 94. But based on destination being accessed, I choose to translate the source differently. So this is called policy NAT. Because like regular NAT doesn't care about, conditional, like is the source and destination this or that, or it doesn't matter. Regular NAT, static or dynamic NAT, if you match the NAT configuration, they're going to do source NAT or destination NAT, and is what it is. But policy NAT gives you more flexibility because in some designs this is what you would want to do. You would want to NAT the source or destination differently based on a condition of what is the source address and what is the destination address of the IP traffic flow, based on any of those two conditions, either based on the source or based on the destination or based on both of them. You may want to do NAT differently into different IPs. That's why they call it policy NAT. Now, once the router is going to do any kind of translations or any system performing that, it has to keep track of the changes made to an IP flow, because as traffic flows back and forth, the router has to know which IPs and which ports has to translate or untranslate. All of those entries are being kept in the NAT or in the translation table. Now, from the ASA firewall point of view, the implementation wise, starting with ASA code 8.3, we have, from the configuration point of view, we have only two NAT types. So NAT has been enhanced from 8.3 and above. We don't have any more like 20 NAT types or a huge number of NAT types. Configuration wise, we have only two NAT types. We have object NAT, which is known as automatic NAT due to the automatic order of NAT rules by the ASA. That's a more advanced topic, how the ASA actually orders the rules, but it's called automatic NAT because object NAT statements are automatically ordered by the ASA. Twice NAT is also known as manual NAT because when you have multiple twice NAT configurations, you have to manually order the NAT rules, so the ASA, the firewall doesn't do that. Of course, the firewall has some default behavior of ordering the NAT rules, but you can change that order. While with object NAT, you cannot change the order. It's fixed and it's let's say automatically chosen by the ASA device. So when you have multiple object NAT statements, let's say that the NAT statements are automatically ordered by the ASA. When you have multiple twice NAT statements, they are also by default automatically ordered, but you can change that order back and forth to influence how a packet is going to be NATed back and forth. But you cannot change the order of the NAT statements with object NAT. That's why it's called manual NAT, twice NAT, or automatic NAT, or auto NAT, the object NAT. Now both options support all NAT types, so it doesn't matter if you do object NAT or twice NAT. With both of them you can do a static NAT, static path, dynamic NAT, dynamic path. The only type of NAT which is supported only by twice NAT is going to be policy NAT. And just to give you let's say a hint in there, because it's another more of an advanced topic, twice NAT was designed to be able to perform in one NAT statement source NAT or destination NAT or both of them. That's why it's called twice NAT, because you have the option to do double NAT, both source and destination, using a single NAT statement. So it makes sense that policy NAT is supported only by twice NAT, because only in twice NAT you can configure both the source and destination, and based on the source destination traffic pair you can choose if you want to NAT the source, the destination, or both of them. So because in the twice NAT configuration you're going to put in there both source and destination, it means you have a policy to match on. You're going to say if traffic flows from A to B, then NAT A or NAT B or NAT both of them. If traffic goes from A to C, then NAT A or NAT C or NAT both of them. So it makes sense. Now, order of processing. So given that you have multiple NAT statements configured on the ASA firewall, like both object NATs and twice NATs, what is the order of preference that the ASA is going to prefer? So it's going to look first where to see how to NAT a packet back and forth. The ASA automatically groups NAT statements into three sections. First, manual NAT. So if you have if a session going to the firewall could possibly match both a twice NAT rule and an object NAT rule, by default is gonna match on the twice NAT rule or on the manual NAT rule, because that's how the ASA that's how the ASA orders the NAT rules. So that's how the ASA orders and processes any traffic against the NAT rule statements. It's going to first look, does my traffic, which I'm trying to forward back and forth to the ASA, match any manual NAT statements? If yes, I'm going to NAT the traffic as the manual NAT or twice NAT rules are telling me to NAT. If I don't match any twice NAT rules, I'm going to go to the second section, which means to the auto NAT or to the object NAT. And if traffic doesn't match, if the traffic from to the ASA doesn't match any object NAT statements, it's going to look in what is called the after auto manual NAT, which is nothing else but still twice NAT, but configuration wise you tell the ASA that those NAT rules should be inspected after auto NAT, which means after object NAT. So configuration wise, manual NAT and after auto manual NAT is the same thing as still twice NAT. It's just a matter of when you configure the twice NAT statement, you're going to tell the ASA where to position that NAT in the ASA configuration. When do you want the ASA to inspect that twice NAT rule statement? Before object NAT, which is by default, or after auto or after object NAT, which you would have to configure the ASA to do that. Now, when they added object NAT, Cisco also added another let's say container in the ASA firewall. It is called which is required for object NAT. This is called the objects. So ASA firewall objects were added alongside with the NAT changes in A3, and it is required for object NAT. It can also be used for ACL optimization, so you can use the object in the ACLs instead of putting a host mapping or an IP address in there. And as the name implies, because it's a object, it can contain a single entry or a single object, which it can be, so because for example, as we saw in the access lists, object groups, because those were group of objects, it means in one object group you can configure multiple entries, as we've done in the ACL section. We've configured in there like an object group of type network, and we added 2 networks in there, and an object group of type service TCP, and we added multiple services in there. So because that was called an object group, it means in one container, in one object group, you can have multiple entries. But because this is called a object, it means in the container which is called object, you can have only a single entry, not more than one. And the object types can be of type network, where you can put subnets, range IP addresses or hosts, and of type service, which can be a protocol service object, like for example for ESP or OSPF or whatever other IP protocol, or it can be a service object for TCP or UDP ports. So it's very similar with object groups. We have network types and service types, but then the difference is that as opposed to object groups, you can only put one entry in any object in there, as the name implies. Now configuration wise, you still have first to identify which NAT type do you need. Do you want to do static NAT, dynamic NAT, or policy NAT? Then you have to identify which of the configuration options, object NAT or twice NAT, best meets the requirements. This is mostly a CCNP topic. And then if we want to configure object NAT, there are 2 steps. You first define the object. So because it's called object NAT, it means that the NAT statement is configured within the object. So you first define the object, and then you configure the NAT statement within the object. And as you're going to see in the object, you define the real IP address that you want to NAT, and then in the NAT statement you configure how do you want to NAT that object, statically or dynamically, and into what do you want to NAT it. While twice NAT, because you can configure in the same line both source and destination NAT at the same time. In twice NAT, you first define the objects or object groups to be used in the NAT statements, depending on if you want to do source NAT, destination NAT, or both of them. You may have to define multiple objects or object groups. And then you configure the NAT statement globally, not under the object or under the object group. And again, it makes sense because in twice NAT you can NAT not only the source, not only the destination, but both of them. So it doesn't make sense to put the NAT statement of type twice NAT under the object, because the object is going to contain a single entry, which is one object, which means you want to NAT something into something else. But with twice NAT, you may want to NAT both source and destination, not only source or only destination. So it makes sense that in twice NAT configuration is being done globally, but then you make use of objects or object groups for your NAT, for your twice NAT statement. Then verification wise, you verify your NAT configuration. Show NAT or show NAT details is going to show you how you configure NAT. You're going to see, of course, also those 3 sections in there. You can also verify the translation table, but of course for dynamic NAT translation, traffic still has to be initiated first to begin to see something in the translation table. Show xlate is going to show the translation table. So what traffic is being NATed into, what IPs are NATing into what out of IPs. And as traffic passes to the firewall, you can look in the firewall state table to see if translation actually occurred, just like a verification. You say show connection long or show connection detail, and you're going to see in there the real address and the mapped address, and if source NAT happened, destination NAT happened in there. And as a verification, once you've configured NAT, you also can use packet tracer to verify if the ASA would NAT the traffic as you would expect. So packet tracer is a very useful tool. Like for example, somebody asks you to, make some changes on the ASA firewall to change some NAT configuration, to change some ACL configuration, to change some IPsec configuration, whatever. You make use of the packet tracer to verify your work, to ensure that what you've done is actually what the ASA is going to do with that packet, so you don't have to like call the users to say, hey, I've done the configuration, can you please verify that it works. You can use the packet tracer to simulate that if the ASA receives a specific packet, it's going to be allowed and is going to NAT it or not NAT it, is going to be allowed by an access list or not allowed, is going to be routed where, out on which interface. So packet tracer, you can use it to verify your work, to make sure that what you have configured, it is what you would expect the ASA to do, which means it should also work in the end from the user's point of view. Of course, it's not bulletproof, because packet tracer cannot simulate all of the inspections the ASA performs behind the scenes. But in most cases, if packet tracer says that traffic is going to be allowed to the ASA, it means that also the user's traffic should work in most cases.